Hello everyone. So in the today's class we are going to discuss about the graphics and the internet. In the previous class we have discussed about some of the input devices which are very necessary for the graphics applications. So in today's class we are going to discuss about graphics in networks and how the graphics can be used in internet and what are all the software required for graphics software. So with this you will be able to understand the use of graphics in networks and the internet and brief view of the graphics software. So graphics network uh, is used for computer networks. I think you have heard about the multi-user environment and the computer networks. Now these are the common elements in many of the graphics application, and various resources such as processors, printers, plotters. So these are the data files. These can be distributed on a network and can be shared by multiple users. So to make available with this, there will be some graphics monitor on a network, which is generally referred to as graphics server or simply server. Often the monitor is going to use some standard input devices that already we have discussed in the last class, such as keyboard, mouse, trackball, etc. So when the system cannot provide input as well as with the output server when it can't connect, so the computer on the network that is executing some graphics application program that can be used for communicating purpose. So that application program we call it as an client, and the output of the program is displayed on a server. So in this way we can make the graphics network as a client and server application. So in a workstation which is going to include a processors as well as a monitor and input devices which can function both the server as well as a client. So when operating on a network, a client computer is going to send the instructions for displaying a picture to the monitor. So that can be called it as a server. Typically that can be accomplished by collecting the instructions into packets before transmission, and instead of sending the individual graphics instructions one at a time over the network. So actually there are different types of software graphics packages which are going to use oftenly for connecting the commands, and that can affect the packet transmission as well as the commands for creating the pictures. So this is how we can use the graphics in the networks. So even it can be extended on the internet also. A great deal of graphics development is now done on the internet. So which is a global network of computer networks. Computers on the internet communicating with any of the system, so which may be using either TCP or IP, that is transmission control protocol or internet protocol. And in addition with this, it may use a world wide web, which is going to provide a hypertext system that allows the users to locate and view the commands that contain the text, graphics and the audio. And a great deal of graphics development is now done on the global collection of computer networks known as the internet. So this internet already we know so about sending the values with the help of World Wide Web, and documents on the internet can be constructed by using HTML, that is hypertext markup language. And this development of HTML has provided a simple method of describing a document containing text and both the graphics and even the hyperlinks to other documents. And HTML is going to provide a method for developing graphics on the internet, and but it is going to have some limited capabilities. So other languages have been developed for internet graphics applications. So next is related with the graphics software. There are two broad classifications for computer graphics software. One is special purpose packages and general programming packages. Special purpose uh, packages are designed for non-programmers who want to generate the pictures and graphs or charts in some application area without worrying about the graphics procedures, and those may be needed to produce such displays. So this interface for a set of menus and allows the users to communicate with the programs in on their own. Some of the best examples of application includes like painting programs, various architectural, business related, medical and engineering CAD systems. These are the some general programming packages which is going to provide some library for graphics application that can be used in a programming language such as C, C++, Java, Fortran and all those things. And even set of packages are also available, such as graphics programming packages called graphics libraries. We say it as an GL that only we are going to use in this uh, graphics application, OpenGL. And other applications are also available, that is VRML, virtual reality modeling and all those things. So these set of functions is often called as computer graphics application programming interface, that is CG API, because the library is going to provide a set of software interface between a programming language such as C++ and the hardware. So when we write an application program in C++, the graphics routines allow us to construct a display a picture on the output device. So it is necessary to have the coordinate representation to generate the picture using a programming package. We first need to give the geometric descriptions of the object and that are to be displayed. So these descriptions are going to determine like a location and what shape of the object it is. For example, if a box is specified by the position on its corners, so only it can be drawn with the help of uh, only it can be drawn with the help of vertices. Say for example, this is one vertex and this is another vertex, say another vertex. So the line joining with these vertices, it can be drawn with a triangle. So with three vertices itself, we are able to have the capability to draw any shape with the vertices. So this is a box. It can be specified by the position of its corners. So only if you specify this corner and this corner, so it may be made possible to draw any box. Same thing, a sphere can also be used by its center position with the help of radius. A sphere can be drawn with the help of some radius with the center of the circle. So these are going to help for understanding the Cartesian reference frames which are used in the process of constructing and displaying a scene. So whatever the scene we are going to display onto the monitor, so it should be in terms of a Cartesian reference frame. First, we can define the shape of individual object such as trees or furniture within a separate reference frame for each object. So these reference frames are called modeling coordinates. So initially, whatever the tree we want to draw, so which is going to have its specified coordinates. So that particular coordinates are going to be converted and that is to be displayed onto the monitor in the form of tree onto the monitor. So now the particular image has been drawn onto the monitor. So whatever the coordinates it has been considered within this reference frame are called as an local coordinates or the master coordinates. So once the individual object shapes have been specified, we can construct any of the model of a scene. So by placing the two objects in an appropriate location within a scene reference frame called the world coordinates. So means within this particular scene, so if I want to draw any image, so first I want to draw a square, or if I want to draw a triangle, so any of these shape and to place these different objects or a model can be placed with a different appropriate locations at this location and this location. So whenever it is going to change with the different locations onto the scene reference, that are called as world coordinates. Those are called as world coordinates. So this step involves the transformation of the individual modeling coordinate frames to be specified positions and orientations within the world coordinate frame. Say for example, we could construct a bicycle by defining each of its parts. Say for example, wheels, frame, seat, handlebar, gear, chain, pedals. So these are all separating different parts of the bicycle, and these are all a separate modeling coordinate frame. So once these all the components are fitted together in world coordinates, so which is going to form a bicycle. Say for example, two wheels and a seat, handle and all those things, this particular sheet. So all these this one parts are fitted together in a particular modeling with a coordinate frame, and these are called as world coordinates. And if both the bicycle wheels are of same size, we need to describe only one wheel in a local coordinate frame, because both are going to have a same size of a wheel. So once if you define, then the same copy we can take it from the local coordinate frame itself. Then the wheel description is fitted onto the world coordinate bicycle description in two different places. So that world two different places means once only we are going to draw the bicycle wheel on a local coordinate frame, then the wheel description is fitted into the world coordinate. So bicycle description can be considered in a two places. So in this way we can construct any of the graphics application. So after all parts of a scene have been specified, the overall coordinate world coordinate specification or description can be processed through various routines onto one or more output device frames for display. So this process is called the weaving pipeline. World coordinate positions are first converted to weaving coordinates and corresponding to the view we want of a scene based on the position and orientation, with what angle, where exactly it needs to get displayed onto the monitor, onto the camera, where exactly we want to take a particular picture. So everything can be considered for a specified scene. So when the object locations are transformed to a two-dimensional projection of the scene, which corresponds to what we'll see on the output device. So this is then stored as a normalized coordinates. Whatever the object coordinates and world coordinates we have considered, so those will be either transformed to a 2D object or 3D objects onto the scene, and we will see that particular 2D object onto the scene. So when it is represented onto the 2D object onto the scene, or it may be 3D also, so that particular scene will be called, and that will be stored in a normalized coordinates, where each coordinate value is ranging from -1 to 1, or it may be 0 to 1 depending upon the system. So either it can be considered this range -1 to 1, or it can be considered with 0 to 1 range. So normalized coordinates are also referred to as normalized device coordinates, since it is using this representation, making the graphics package independent, so that the coordinate range for any specific output device. So this is how which is going to be considered in this figure, the transformation sequence of from modeling coordinates. So this is a modeling coordinates. Modeling coordinates we are going to consider for a three-dimensional scene here. Then object shapes can be individually defined in the modeling coordinate systems. So these two are modeling coordinates. One is a type of cylinder and one is a type of different cube. So now these two will be coordinated, and object shapes can be individually defined in a modeling coordinate reference systems. Then these shapes are positioned within the world coordinates. So these are the modeling coordinates. Say for example x, y and z axis. Same thing here for this object also. So these two modeling coordinate objects onto the scene will be now converted into the world coordinates. So which is going to have the object shape can be individually defined in the world coordinate scene. Next, world coordinate specifications. These world coordinate specifications are transformed through a weaving pipeline, to weaving and projection coordinates, and then it can be normalized coordinates in the form of 0 to 1 range. So this will be considered a 0 in x-axis, y-axis and the z-axis. So these are called as normalized coordinates. And once the normalized coordinates are done, at the final step, the individual device driver is going to transfer the normalized coordinate representation of the scene to the output devices. Either it may be in the form of monitor, plotter or any other devices by considering its device coordinates. So this is how it is going to briefly discuss the sequence of coordinate transformations from modeling coordinates to device coordinates for display, which is going to contain the view of the two-dimensional object. Initial modeling coordinate position. So those are considered as modeling coordinates of x-axis, y-axis and z-axis. So the coordinates will be referred to as XMC, YMC and ZMC, indicating that X modeling coordinates for X, Y and Z axis. So this is a illustration in transferred to world coordinates. Now world coordinates, then it's weaving and projection coordinates, then on to the left hand normalized coordinates, and finally to the device coordinates. So world coordinates will be considered XWC, YWC and ZWC. Then weaving coordinates VC, X, Y, Z related with all the X's. Then the projection coordinates PC, XPC, YPC and ZPC. Then lastly, it will be converted to normal coordinates. These normalized coordinate will be at the final step, depending upon the individual device drivers, these are going to be transferred to the individual device coordinates. So this is a sequence of the modeling coordinates to a device coordinates. So this is a modeling coordinate representation of the sum of the 3D object, and this is a device coordinate representation onto the monitor. So in this way, so modeling to device coordinate, these are the 6 different steps it need to follow, from modeling coordinates to world coordinates to weaving coordinates to projection coordinates, then normalized coordinates to device coordinates. And these are the integers within the ranging from 0 to x max, y max value. So x max, y max value means the total screen area. Total screen area. Normally we consider the bottom left corner will be x min, y min, and this will be considered as x max, y max. So entire screen area of the monitor will be get displayed with a particular range of the device coordinates, and it may be depending upon the different output devices also. So in addition to the two-dimensional position, XDC and YDC on the weaving surface, the depth information for each device coordinate position is stored for use in a various visibility and the surface processing algorithms. So this is all about the explanation of those things. So now let us move to the some of the graphics functions which are going to deal with for any of the graphics application. There are general purpose graphics package which is going to provide the user with a variety of functions for creating and manipulating the pictures. And these routines can be broadly classified according to whether they deal with the graphics output or input, and attributes, transformation, weaving and subdividing the pictures, or general control. So the basic building blocks of a picture are referred to as graphics output primitives, and these are going to be considered with the character strings and geometric entities such as points, straight lines, curved lines, filled color areas. Usually it uses say for example polygons and any other shapes with arrays or color points. And there are some functions for the displaying also, such as displaying complex shapes such as spheres, cones and cylinders. And even it has some routines for generating output primitives, which is going to provide a basic tools for constructing pictures, and attributes which are the properties of the output primitives. That is an attribute which is going to describe how a particular primitive is to be displayed, and which is going to include the color specification in terms of line styles, text styles and area filling patterns. So even we can change the size, position or orientation of an object within a scene using geometric transformations. So after a scene has been constructed using the routines for specifying the object shapes and their attributes, a graphics package projects a view of the picture onto the output device. And there are some weaving transformation functions. These are used to select a view of the scene. The type of projection can be used and the location on a video monitor where the view is to be displayed. And other routines are available for managing the screen display area by specifying its position, size and structure for three-dimensional scene and the structure. And for the three-dimensional scene, some visible objects are identified and the lighting conditions may be applied depending upon the different applications. And even the interactive graphics application is going to be considered with some of the input devices by mouse, tablet and joystick. So those input functions are used to control and process the data flow from the interactive devices. And some graphics application packages also going to provide the routines for subdividing a picture description into the named component parts. And these are the other routines may be available for manipulating pictures components in various ways. And finally, a graphics package also contains a number of housekeeping tasks such as clearing a screen display area to be selected color with the initializing parameters, and even it is going to have a different set of functions for carrying out these codes under the heading of control operations. So these are the different varieties of graphics functions are available to make it possible to have the different types of graphics application, and which is also going to support with the different software standards. The primary goal of a standardized graphics software is a portability. So whenever it is going to have a packages, and whenever it is using different functions, all the functions are going to be run, and that particular graphics software is going to run on different application as well as on different platforms. So that should be a standardized graphics software which is a portable one. And when the packages are designed with standard graphics functions, software can be moved easily from one hardware system to another, and even it can be used for different implementations and applications. And there are some examples with international and national standards planning organization in many of the countries. They have developed some standard for computer graphics with working on different standards led to the development of graphics kernel system, GKS. This is a one software standard designed in 1984. This system was adopted at the first graphics software standard by the ISO, that is International Standard Organization, and ANSI, that is American National Standard Institute. Although these GKS, that is graphics kernel system, was originally designed as a two-dimensional graphics package, and a three-dimensional GKS extension was also soon developed. So the second software was considered as second software standard to be developed and approved by the standard organization was FIGS, that is Programmers Hierarchical Interactive Graphics Standard, which is an extension of GKS, and increased capability of hierarchical object modeling and color specification with surface rendering and picture manipulations are provided by the FIGS. And even subsequently an extension of FIGS are called FIGS Plus was developed for three-dimensional surface rendering, which is going to have the capabilities available with the FIGS itself. And GKS, that is graphics kernel system, and FIGS packages were being developed for graphics workstations from Silicon Graphics, that is SGI, which became an increasingly popular one, and normally this can be used for any of the workstation. So nowadays whatever the workstation are going to we are using, these workstations are going to came with a set of routines called the GL, that is graphics library, that only you are going to study and use in this course. So GL is a graphics library which very soon became a widely used package in the graphics community, and even it have become a de facto graphic standard also, and were designed for fast and real-time rendering. As soon as this package was being extended for other hardware systems, even portability can also be increased. And as a result, so this OpenGL was developed as a hardware independent version of GL in the early 1990s. So this graphics package is now maintained and updated by the OpenGL Architecture Review Board, and the OpenGL library is specifically designed for efficient processing of three-dimensional application, but it can also handle a two-dimensional scene descriptions as a special case of three dimensions where the Z coordinate values are 0. So whenever we go for writing the different coordinate systems like x, y and z coordinates, so if we consider the z value as 0, now this is called as XYZ representation is called as in 3D, and if we made Z coordinate is 0, only it contains X and Y values. So this is a simple representation of 2D in this graphics library. So you are going to see all these examples and how to specify the coordinates, everything in your further classes. So now try to remember this OpenGL library, which is designed for efficient processing of any of the application, graphics application in 2D and 3D. And the screen descriptions we can be designed with the X, Y and Z coordinates. So these graphics functions in any package are going to be typically defined as a set of specifications independent of any of the programming language. There is no language binding which is then defined for a particular high level programming language. So this binding gives the syntax for accessing the various graphics functions from that language. So the language binding is defined, make best use of the corresponding language capabilities to handle various syntax issues and the data types and parameter passing and the errors. So some of the specification for implementing graphics package in particular language are set by the ISO. So that will be considered as C and C++ languages. Both are one and the same. And other OpenGL bindings are also available. Even it can be used with a Java and Python. But here in this course, you are going to learn this binding with C++ or C or C++ binding for OpenGL as a framework. In this course, you are going to study C language or C++ language with this binding for OpenGL as a framework. For discussing some basic graphics concepts and the design and applications of graphics packages. So today we have discussed about how the graphics is used in networks and graphics on the internet and how it can be considered as a software with some of the standards and the packages. The next class we are going to discuss about that OpenGL library in detail. So with this, you will be able to understand the graphics networks, how the graphics is used in networks and internet and the software. So these are the two important questions for the today's class. Write a note on graphics in networks and the internet and explain the graphics software with its coordinate representation and software standards. For this today's class, you refer the chapter 2 subsections 2.6 to 2.8, page number ranging from 68 to 73. Thank you.